All right, now we're going to do activity 352. This one, a equals 4, 3, -3, -2. So this ought to have some repeated eigenvalues. The determinant of 4 minus lambda times 3, -3, -2, minus lambda equals 0. So then 4 minus lambda times -2 minus lambda, and then minus -9, so it's plus 9 equals 0. So now we have lambda squared, and then my linear terms, I've got a -4 lambda and a +2 lambda, so minus 2 lambda, and then minus -8, +9 is plus 1 equals 0. So then that factors as lambda minus 1 squared equals 0. So lambda's 1 repeated twice. So now if I subtract 1 from there, so subtracting 1 from the diagonal gives me 3, 3, -3, -3. Okay, so my columns are exactly the same. So then some good column numbers might be 1 and -1. That would give me, that means B1 equals 1 and -1. Okay, now I found part A asked me to find the eigenvalues. I did that. Part B, find the eigenvectors, V1, and then find the straight line solution, dx dt equals ax. Okay, so the straight line solution is that so x of t equals e to the t times 1 -1. Okay, so that means that if I try to plot this, I'll just switch to Desmos. You guys don't need to see my bad handwriting. Smaller. Okay. So the x part was e to the t, and the y part was -1 times e to the t. And so then the solution then goes like, so a goes from 0 to 3, and yeah. There it goes. Okay, so the straight line solution looks like that, which is basically like the y equals x line. Nope, y equals -x line, right? Okay. Now, so that's my straight line solution. So I found a solution. Part D, I found one solution. Now, let's take another vector, and that's not our eigenvector, and let's compute that. So then if I try, say for instance, one of my favorite vectors would be 1, 0. Let me go back to showing it here. So I'm just going to find another vector, so 3, -3, 3, -3. This is my matrix with the diagonal subtracted by the eigenvalue. And pick a favorite vector, 1, 0. This one thing I like. So that equals, so that's 3 times 1, -3 times 1. Okay, so then that means I'm just 3 too much. So then if I had 1/3 there, 1/3, 0, that's going to equal 1, -1. Okay, so I found a vector that the matrix with diagonal subtracted by eigenvalue times that gives me the eigenvector. Okay, so then this is a vector of the form alpha v1. So v2 equals that. So this is v2. So v2 equals 1/3 0. Okay. So the second solution is x2 of t. The t is there. X2 of t equals e to lambda t. So lambda is 1 times v2 plus t v1. So in this case, it's 1/3 plus t times that vector, t and negative t. Okay? And that gives me my two solutions. Sketch several solution curves for the system. Okay, let's see if we can kind of go to Desmos and sketch a few solution curves. We could also do this in Sage. So then here, I've got something to the effect of e to the t times over 3 plus t e to t, and then negative t e to t. So A increases, it's kind of going just a little bit off from that. So if I zoom out a little more, you can see like that. And then any other solution of the system is going to be some multiple of that. So let me do 10 times, but if I could do times 10 for each component, that'd be a scalar multiple of this solution, still be a solution. And then you could do different combinations, adding this to that, and so on and so forth. Those would be also solutions. And so that would be add different scalars. So I could add this to that, I could add this plus 2 of these, or 2 of these, or like -3 of these plus 2 of these. Any linear combination of these two solutions will be another solution. And that's how you could plot a bunch of different solutions. Let's just, for kicks, let's do it in one time. Let's do -3 times the first one plus the second one. Okay. So then, so -3 times e to the t plus 2 times e to the t. Now, of course, you could simplify this if you'd like. I'm going to do 2 times plus 2t e to the t, comma, and then negative, I'm multiplying by -3, so that gives me +3 e to the t here. I'm doing -3 times this component plus 2 times this component minus 2t e to the t. Okay, so then that's a slightly different version. Slightly different solution. That's a slightly different starting point than the others. This one starts here, that one starts there. That's kind of interesting how they're all gonna, I bet they're all gonna kind of curve like that if you're far enough starting way. Interesting. So more things like that would plot more curves. It might be nice to have one that's on this side over here, stuff like that. All right, that completes this video.